So it is. So welcome to Auth Part 2. Let's get to it. So by the end of this lesson, you should be able to verify users' identities in Rails. You should be able to issue signed tokens to users and maybe differentiate between authorization and authentication. We haven't gotten to that one the last few times, but we'll see. Once we've created a user with a secure password in Rails, how do we tell that somebody is who they say they are? They make an account, now they got to log in. So this is all logging in. The high-level overview is that we're going to client sends over a username and password to our server. We're going to get the user. We are going to let's see, I'll put this as, we're going to compare hashes. So we're going to hash their password that they sent us. We're going to take this user record that we pulled out of the database. We're going to compare the hashes, make sure they're the same thing. If they're not the same thing, we send back a 401 and go, fuck you. Wrong. Now, if they're right, then what we're going to do is generate a token. Token is like a valet key. This is, or a membership card or something like that. This is proof that you have logged in. So we send them back this token. The reason they need that token is otherwise every single time they want to do something that requires you being logged in, we got to send the username and password over again. So we can give them this token instead that goes, I've seen them, hand stamp at the club. That's what it is. You've already been through the bouncer, you paid, you can come back. That's a token. So this is the workflow that we're doing today.
Hey Kyle, can those tokens be cached?
Should be. That's what makes it so that, like, when you close your browser and open it again, you don't have to log into every single thing that you're in. It's because they're keeping track of those tokens in local storage. More questions about this workflow? Cool. So let's do step one from yesterday. I'm going to make a new Rails API, install bcrypt, make a route to create a user, make a controller to create a user. Nothing special in any of those. Then we're going to create a user model. What was the thing that we put in the model?
Has secure password.
Has secure password. And then our migration for that model, what's the thing that's different about that?
Password digest.
Password digest. It's called password when it comes in. It's called password digest when we're storing it. Cool. So we'll put a couple minutes on the clock. All right, do it. Go. All right, so fist to 5. Fist is what we're supposed to be doing. 5 is I got that hash coming back, baby. Thank you, thank you, thank you. Seeing lots of 5s. Excellent. So let's go through this together. If you're struggling, follow along. Let's see, projects, practice. So I'm going to call this Auth practice part 2. And then we're going to Rails new API backend. First thing we're doing, going into that, well, how about we go into the right folder? We're going to go into the gem file. We're going to install bcrypt, bundle install. Cool. And then our next step, we want to make routes and controllers and stuff. Rails G controller users. I am going to Rails G model user. I'm going to go over to my router. I'm going to make resources users, but solamente create. I am going to go over here. I'm going to make a create action. User create. I'm going to take in a username. That could also be called profile, handle, whatever. Username isn't anything special. Password has secure password is going to translate password to password digest. Everything else is just for our app. No magic behind this. And we fire it on back. And it's so. We go over to the model. Has secure password. And then we're going to go to the migration. T-string username, T-string password digest. If we run that migration and we serve it up, we just wait for Postman to load.
So did you choose to render it as a hash to get uniform data?
A little bit. So one of the reasons I like having a top level key that I'm attaching the thing to is there's other things that you might want to include at the top level also. Like you can include more than one piece of data in your response. You might also have metadata that you want to keep about the response, like I'm giving you back 10 users, but there are 10,000 of them. And so if you'd like to get the next 10, here's this URLs. Any number of things like that we might want to include in the response. So I feel like it makes sense to namespace it. That's a good question. All right, so if I try to make Kyle into a user, hey, there's my hashed password. Who can give me a good definition of hashing?
It takes your password and then uses an algorithm to add some extra letters and then like add up the totals of everything and hash all of that, which gives you a completely random, hopefully unique password.
Cool. Not too bad. I want to hear everybody's definition of hashing. So I'd like you to take 2 minutes, see if you can wrestle the concept of hashing into words. It's difficult, and then Slack it over to me. 2 minutes. We're going to be doing more of it today, so I want to see where everybody's at. All right, pencils down. Send me what you got. What is a hash? Haley, I really like your answer. Would you be willing to share it?
Sorry, yes. So I said a hashing function takes in a string and then uses an algorithm to turn that string into a hash that is entirely different from the original string. This new hash value should not be able to be duplicated with any other original value, and you can't decode the hash to the original value.
Cool, very nice. So a few of you mentioned passwords. Passwords are one use for it. We're actually going to see another one today. We also saw that they get used to identify git commits. So you take all the changes that are happening in this commit and you hash those, and then that's the ID of the commit. So we can use hashes for a whole bunch of different things. But core idea is that we're getting some hopefully original string that's one directional, can't be reversed. Encryption can be reversed, hashing can't. A few people said something about like adding characters. That's not a terribly useful way to think of it. If you want to know how these algorithms work step by step, it's actually fascinating. Hang on. Let's see. Oops. Let's do knowledge. Cool. So like, here's the MD5 hashing algorithm. So we start with this pattern, and then we transpose some of these sections. We bring in new data. We make a new section. And when we use and, or not, so this is binary. We'll take two things, and when we're combining them, and, or not can't be reversed. That sort of makes sense, right? Because if you have 0 and you say not, you get 0. If you have 1 and you say not, you get 0. So it'd be the same either way. That's why these things are only go one direction. And so if it's longer, then you do it kind of like a blockchain, or instead of starting with this pattern, you start with the pattern that you had at the end of the last iteration. That's hashing. Cool. Other questions about how hashes work? Cool. Let's talk through how we do authenticating users. So we're going to create a login route. That's step 1. Here's what it looks like. Go into our router, and we're going to say if somebody makes a post request to log in, I want to send that to an authentication controller's login action. This is a little bit different than most of the Rails stuff we did in Mod 2, because this isn't a resource. Login isn't, we don't create, delete, update. We don't do that kind of stuff with it. We're taking the verb post and the path login, and we're routing this to a standalone controller's special login action. We can also do that. This is an example of an architecture pattern called RPC, remote procedure call. It's basically just calling a function on somebody else's computer. Sometimes that makes more sense than what we do with REST. REST is this stuff. We create a user, we delete a user, we update a user, we read users, we list users. Those are RESTful actions. I would like to call the login function on this computer. That's a remote procedure call. Different pattern. And you can mix and match them like we're doing here. All right, so I've created a login route. Now I'm going to create a login controller and action. So I'm going to say Rails G controller authentication. Okay, controller's made. Actions made. Step 3, I'm going to look up the user. So who's the user? Well, how about I user.findBy username is params username. So I've looked up the user. this was also in this diagram. That's this right here. So what does it mean if the user is nil here?
They don't exist yet.
They don't exist yet. So think about that in terms of like a login flow. What do we do?
Create a new user.
Probably not.
Go back to the start and tell them to create a new user.
Yeah, you got, or like tell them like, yeah, that doesn't exist. So we'll say if not user, we're gonna render something like this. We can say error, no user with that username. Now we can even give it a status of unauthorized. That's going to give it a 401 status code. So when we're fetching, we can say like, hey, was that response okay? And it'll give us an okay if the response code was started with 200 or 300. Not okay if its status starts with 400 or 500. That's a 401. Okay. So hey, even with just this, we should be able to fuck up a login, bare minimum. So if, oh, actually, do it this way. So let's say let's say it worked. We can send back a status of created. So 201. All right, let's see if we can get this far. So we serve it up. We go over to Postman. Instead of posting to users, now I'm posting to login. So if I do it right, I should get my user back with this 201 created. If I do it wrong, Duncan's not in my database right now. So I should get a 401 unauthorized. Cool. So I've looked up the user. Now I want to authenticate them. I want to make sure they actually sent me the right password if they do exist. So instead of just doing that, I want to say, okay, well, if not at user.authenticate. Authenticate is a magic new method that we got on any instance of a user model because of has secure password. We don't have to write the definition of authenticate. Has secure password gave us that one for free. And so what we pass into that method is the password that they sent over. The authenticate magic method does all the shit for us. It compares this plain text password, it hashes it, it does all the cool stuff with the salt. All that stuff we get for free with this method. So if that didn't work, we could say something like wrong password. Otherwise, it worked. So let's see if that's the case. If I serve it up, all right, so if it's the wrong user, no user with that username. If it's the right username, but the wrong password, wrong password. If it's the right username and the right password, woohoo. That's step 4. last step in this. There's a couple parts to this, but we need to create our hand stamp for the bouncer. I'm gonna pause for a sec though. When you do these conditionals, I'd recommend doing these negations like I did. If not user authenticate. And the reason why is when somebody else is reading this code, it's a lot easier if what we call the happy path, the thing that we want to happen, is at the end. All the little tripwires, all the things that could go wrong, we put that up front, but I can skip to the end for whatever the thing that should happen is. Because here's what this would look like if we did it the other way. If this is if user and if user.authenticate, then this moves into here, that goes down here, and this goes here, and this goes here. So if I'm just scanning this code, and people scan code, they don't read it. Like, it's all you'd ever fucking do if you had to read all the code that you read. You scan it. You're looking for something. With this, all right, that's how it works. In this one, it's tucked in between all of these things. It's in the middle. That's way harder to find that. So that's why I'd recommend doing these negations instead. Organizes your code a lot better. For anybody who was in my refactoring DOM calculator thing yesterday, similar kind of thing. Sweat the structure of your code. Sweat the names you use. So many of the gymnastics I see programmers do at all skill levels are like these self-created hells where if you spent more time on the structure of your code, if you spent more time like sweating over a good name, you wouldn't have these problems. Cool, end of soapbox. All right, so I need to make a token here. But I'm gonna pause. Questions about any of the steps we've done so far?
So this is probably outside of the scope of this lesson, but is there anything with this that you could use to get rid of the cyclomatic complexity?
Such a good question. We can reduce the cyclomatic complexity a bit by combining these two conditionals. So if we did something like that, that substantially reduces the cyclomatic complexity. And is also like just better in general. However, Rails people don't seem to give a shit about this stuff like I do. So if like you want to do it the Rails way, I see this kind of stuff more. But this has a cyclomatic complexity of 2 versus this, which has a cyclomatic complexity of 4.
So is that why most websites just tell you like wrong username password combination?
That's not why, but if they're doing that, they're probably doing something like this. The reason they tell you that is if you know that this is specifically what's wrong with it, you go, okay, cool. thanks for doing half of my work for me. Instead of having to guess a correct username and guess a correct password, now I can split that into 2 steps. If I can find a good username, awesome. My job is half done, and now all I need to do is figure out how to crack that one person's account. If I have to do both of those at the same time, that's an exponentially harder cracker problem to solve. Now, could we get the cyclomatic complexity down to 1? Yes, but not in a way that like Rails would like. It might not even be possible in Ruby. We'd probably have to do something functional for that. But yeah, with functional programming, you'd probably get it down to 1. Cool. Other questions about anything we've done so far? Made a login route, made a controller in action, looked up a user, and called this authenticate method on them. That's all we've done.
Kyle, whenever I use like the like I try to do it like that with the user params defined on the bottom under private under my controller, it doesn't work for some reason. But if I type it all out, I just didn't know.
So if we were going to do, well, you're not passing in all the user params. That might be part of it. So if you wanted to whitelist these, you do something like private and we could params dot whitelist. Let's see, and permit takes in.
Those require user permit username and password.
Either way, it'll add those in. So we could do something like, and then I can't remember, are these in an array? Username, password, or are they just in like that?
They're just like that.
All right, cool. So if I did something like that, then this would just be something like user params, username, and this would be user params password. That should still work though. Let's give it a shot. Yep.
So then if you're doing that though with the require user, you have to do a higher level thing of user that contains that object.
Because we're that's because we're not in the user's controller. It'll do it automatically for you if you're in a user's controller. But like the shit that's getting passed into this right now is probably in the thing called authentication. Yeah, there it is. It'll automatically try to wrap it in the name of the controller. So if I said require authentication, I'd get that for free. But otherwise, I got to do that. Cool. Other questions about what we've done so far? Okay, before I do the token thing, I want you to get this part also. Token thing has a couple kind of weird steps to it. It ends up being like 3 lines of code, but they're not intuitive. So let's get this far, and you give me a couple minutes. Go.
Okay. I can let him know. So the change is that you're coming with the food, right? Okay, great. Great. I'll fill him in. We'll see you then. Sure thing. All right. Okay, bye-bye. Kyle?
Mhm.
Are you in a class?
Yes, I am. All right, give me some physical indication. I have no idea what I'm doing. 5 is I'm caught up. Thank you, 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 thank you. All right, cool. We're in pretty good shape. So let's talk about this token piece. So what a token is our hand stamp to get back into the club. We're going to use a token system called JOTs. The most confusing thing about JOTs is how they're spelled. JOT is spelled JWT. I didn't come up with it. It stands for JSON Web Token. And here's what they look like. This is a JOT. JOTs are encoded. They're not encrypted. This is an important distinction. There's 3 different kinds of like cryptographic things that we're going to talk about. We've talked about hashing. Hashing is like a one-way scrambling. We're now seeing encoding. Encoding is like pig Latin. It's 2 ways, but it's not any more difficult to go one way or another. So in this case, this is base 64 encoded. What's base 64 mean? Somebody tell me.
Each individual character has a value of up to 64.
Yep, correct. So if decimal base 10 gets us 10 possible values, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. If we also add the lowercase alphabet, we get 26 more characters. We get 36. All right. If we also add the uppercase alphabet, we get 26 more characters, which will take us to 62, right? Somewhere in there. And then this also has underscores and I think dashes. So we get 64 possible values for each thing. We translate this back into just lowercase things. So we can have a lot of density in here. That's why we would encode it in the first place. It's not secret. If you have a JOT and you paste it into this tool, it'll tell you what's inside the JOT. No secrets. But we can do this in a much denser way than if we were sending these things directly. And it just gets stored as one long string of characters. So the last piece of this is this signature. So we have, all right, here's some metadata about our token. Here's the version we're using, all that kind of stuff. This is our data. This can be anything we want. This can be the user's entire record. This can have timestamps. This can have anything we want. We make this part up. This is the payload. And dun, 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 hashes back to the rescue. So this, and also I should note, check out the colors on these. These line up directly to this. The red part here is the headers, and then there's a dot. Then there's this purple part, that's the payload, and then there's a dot. And this last part here is a hash. We take these first two parts and hash them, and this is the resulting hash. Now, there's one other kind of cool thing about this resulting hash is that we actually use a super top secret thing to help us generate this hash, which means that you can only generate this hash, not just if you have the header and the payload. You have to have the header and the payload and the super top secret information. If you have those, you can generate this hash. The reason why this matters, and this is cool as fuck, is that I can, since this is just Pig Latin, I go, I'm not John Doe, I'm Jane Doe, mwahahaha. That hash isn't gonna match up anymore. So that's how I can tell whether or not somebody tampered with my token. That's pretty badass. So that's what we need to do. We need to generate this JOT token, and then we need to sign it. So when we're using a hash to verify the integrity of something, that's what it's called. It's called a signature. So we make a JOT and sign it. Let's do it. So we actually need a library for this that doesn't come in for free with the gem file. So down at the bottom, we add gem JWT. Then we're going to bundle install that. Ta-da. We go back to our authentication controller, and we're going to start by making the payload. So you can say the payload is some hash. We can say we're going to keep the user ID and fuck it, that's it. We can put anything else we want in there. We can put their username. We could put their password, but don't do that. Put anything we want in that payload. And we're gonna have a secret. We can start with just a string. Top secret, like that. And now we're gonna make our token, which is jwt.encode, and we're gonna encode the payload with the secret. And then we send back the token. Cool. So let's see if it works. All right.
Hey, Kyle.
Yep.
Do we have to require JWT in our authentication controller?
No, it should get auto-loaded. Hey, look at that! It's a JOT, motherfucker! And if I take this JOT and I put it back in that jwt.io, hey, look, it has my user ID. make a payload, get a secret, encode the payload with the secret, send it back. That's it. If you have this token, you are logged in. One last thing. Rails gives us a secret that we can use. It's in Rails application secrets, secret key base, I think. I wrote it in these notes because I always forget it. Oops. Except, I don't even think you need that part of it. It might just be Rails application secret key base. I'm going to put a buy bug in here and see if that's the case. So if I run that and I make the request, get buy bugs, what's the secret? There we go. That's it. Rails application secret underscore key underscore base. And then it sends me back a token. Pretty cool. Questions? Cool. Just like tomorrow, or just like today, tomorrow we're going to start by doing all of these things. You should be able to make a new user and hash their password. Then you should be able to look them up, verify that they are who they say they are, make a token, send it back to them. And the last part of this series is we're going to figure out how we make sure that a token is legit. And then we're going to figure out how we use those tokens so that some resources are secret and other resources not so much. Questions before we break? Thank you all so much. Toodaloo-hoo.